All the action principles of unified field theory are found symmetric with respect to charge, parity, or time, or the acronym CPT. That is, if you invert reality, making a CPT inversion, you'll find action principles which will look the same in both sides of the apparent world that we have, and a CPT inverted world. The action principles are found invariant under CPT inversion. Now understand what a CPT inversion actually is. A CPT inversion is a three-part inversion. First, number one, is when you change matter into antimatter, and this represents an inversion of the charge condition. Two, parity is to invert the image into a mirror reflection. And three, T, the time component, implies that the time is running in reverse. And so we have a significant change, sort of a reflection of the apparent world with the CPT inversion, which is actually running in reverse time. Unified field theory unifies special relativity and the strong force and the weak force and electromagnetism, and is otherwise agreeable with the standard model of particle physics, and therefore is a very comprehensive theory. Hence, the CPT symmetry condition is very significant. You might rightly ask, are there any known laws of physics that are conflicted with the CPT symmetry conditions? Well, general relativity doesn't seem to offer a hope of finding a conflict with CPT symmetry. It's likely agreeable, even though it's not been included in unified field theory, because gravity has not been unified with the other forces of nature. About the only place there could possibly be a conflict with a condition that laws are described as invariant under CPT inversion is with the asymmetric second law of thermodynamics. However, taking the mathematical underpinning from statistical mechanics as a given leads to paradox, that it must have been, for example, that the universe came into existence in a condition of very low entropy, or other paradoxes that the entropy must have been higher than it is today if we assume that the universe came into being in thermodynamic equilibrium. And this is a direct contradiction of the second law. William James Sidis actually offered some remedies of these problems we have with the second law, in that it's possible for the second law to run in reverse in some pockets of the universe. And so it's quite conceivable that on our apparent side of the CPT inversion, entropy is found to increase according to the second law. And on the other CPT inverted side, the entropy decreases, going in reverse time. And so we have no longer a conflict with the second law, with this interpretation. So it's very compelling to see reality as a CPT symmetric world with two sides, actually agreeing with Boyle, Fenn, and Turok in their 2018 paper, The CPT Symmetric Universe. Particles most certainly exist. We have all the particles of the standard model of particle physics, the subatomic particles. We have atoms that are composed of subatomic particles. We have molecules made of atoms. We got cells in a body. We got organs in a body. We got entire organisms, and we have communities. We have the biosphere, the Earth, the solar system, the galaxy, and beyond. And so these boundaries, or these particles that are represented by boundaries, most certainly exist. We could say that they cannot be known exactly in the sense of where they're located in space-time because of Heisenberg's uncertainty principle. However, that has no bearing on whether they exist or not. They most surely do exist. And because these particles exist in forward time, we can speculate about the CPT inversion and the existence of such particles in the CPT inverted reality. And that brings us back to the particle wave duality, because certainly the particle side of the duality is well described as particles. And that makes the wave side very interesting. I'm thinking that the wave side is an echo chamber provided by the two sides of CPT inversion. And so the wave side is an echo coming back from the past, of the particles going in reverse time, leaving an echo in the present moment as a wave or a possibility wave. And in this way, I'm speculating that the particle wave duality turns into Stuart Kauffman's Poe's realm of warm-body quantum mechanics. Likewise, the particle wave duality also turns into a two-sided theory of time, where the two sides of the CPT inversion are held as a unified reality, described as the particle wave duality. Albert Einstein thought his theory of general relativity was so beautiful that it had to be correct. Many other scholars also thought that beauty and aesthetics played an important part in the mathematical equations that describe the laws of nature. It is worth noting that this deeper connection to beauty is not normally thought as part of science proper. Rather, it hints at something completely different. It hints not of a hard-nosed empirical science that is strongly dependent upon Karl Popper's falsification principle. In the horror of horrors, it hints of something metaphysical. In particular, it hints of intuition. Were we to assume that reality is driven by arbitrary mathematical equations that make a forward-looking determinism, aside from a presumed accidental randomness that happens from time to time, a worldview that has no room for intuition, a worldview that has been cleansed of intuition? Were we to agree with Macbeth that life is a tale told by an idiot, full of sound and fury, signifying nothing? Macbeth's attitude actually agrees with Steven Weinberg, who is quoted saying, "The more the universe seems comprehensible, the more it also seems pointless." What is missing is an appreciation of metaphysics, that is, a metaphysical grounding from which we can build science. We first have to be able to look at reality in a meaningful way in order for us to even conduct science. If we can't trust our own observations, our own perceptions, our own intuitions, then it's very doubtful we could have any science at all. So it is necessary that there is a metaphysical grounding which provides the precondition for us to look at reality in a meaningful way. But when we look at reality, we are also looking at ourselves. So we must be able to look at ourselves in a meaningful way. Otherwise, life is a tale told by an idiot. But could it possibly be that we live in a meaningless universe and just don't know it? Well, this seems very unlikely because we spend a lot of effort actually studying reality and doing things and looking at ourselves. And if it was all meaningless, it's very doubtful that we'd even bother looking. So we may take the metaphysical grounding as a precondition, as a necessary precondition that comes before science. And what must be in reality for us to look at ourselves in a meaningful way? Well, it must be that there is something like a mirror in reality, not just in mind, but in an actual reality for which we can look at ourselves, perhaps in a real mirror, or look at reality in something that's actually hardwired into reality. So there must necessarily be something in reality that's tantamount to a mirror from which we can study ourselves and reality. And what better mirror than a CPT inversion, according to my theory? And so the CPT inversion of our apparent reality, that is the other side of time, is like providing negative film. In forward time, the negative film is developed into prints. And so we have our potential mirror, according to my theory of two-sided time. And from this mirror springs forth our memories from the past. And so we can look at ourselves and reality in the form of innate memories that are a part of nature. Now, in theory, it is possible to get all your knowledge through this grounding, through this intuition that we can tap into. Or we can practice meditation and center ourselves. And if you believe some of the esoteric traditions, you should be able to enter into the Akashic library in order to get memories from the past. But this is now getting far beyond empirical science. And I want to return now to empirical science and actually try to use the developed theory to make predictions that are open to testing and can provide a possible refutation of the theory. After all, just because I happen upon a metaphysical grounding which is found necessary doesn't automatically mean I discovered the right mirror in reality, even though I can presume that there is such a mirror. Douglas Hofstadter has proposed his mirror, a self-referral mirror, that he describes as a strange loop, which differs from the mirror I'm describing. But I would say, for example, that his mirror, since it runs in forward time only, is not the right mirror. Nevertheless, I would say that Hofstadter's mirror is a direct result that follows the metaphysical grounding which I have described. With grounding in hand that is found necessary, I may now answer Macbeth by quoting Hamlet. There are more things in heaven and earth, Horatio, than are dreamt of in your philosophy. To summarize the theory of two-sided time, we have the particle-wave duality that comes with a wave side and a particle side. The wave side is now characterized as an echo returning from the past and showing itself in the present moment. This echo is generally described as a memory. Now, depending on how complicated the particle is, the memory can become more and more elaborate and richer. So therefore, the theory predicts that we should be able to measure memories or changes in the wave-like property of particles based on their history, and those changes can represent memories. Therefore, the wave-like side of the particle-wave duality is not some static wave function of quantum mechanics, but in theory can become richer and richer depending on history. If verified, this is quite a significant development because it now provides a foundation for a science of memory based on the particle-wave duality. And so we may study these dualities with different materials or liquids, like water, for example, and discover more and more interesting properties of the wave-like structure of water or other things. Perhaps not surprisingly, there already is some experimental verification of my prediction coming from scientists that study homeopathy. In case you don't know, homeopathy is an alternative medicine based on the idea that water can be imprinted with a memory of a substance. The substance is generally a toxin, but has been removed from the water by a dilution technique, but leaving the memory behind with the purified water, which is now harmless because it has none of the toxin in it, but has a memory, which is used as a medicine. Now, whether you believe in homeopathy or not is not the main issue here. But what is the issue is whether or not water, for example, can be imprinted with a memory. And there is some evidence to suggest that very thing. A 2006 Russian study by Vladimir Korenban et al., titled Absorption Spectra of Electronic Homeopathic Copies of Homeopathic Nosodes and Placebo Have Essential Differences, showed statistical differences using absorption spectroscopy. I would expect changes in the wave-like property of water to reflect itself in the absorption spectrum, as found here. And in any regard, future work in homeopathy may focus on how water is imprinted with memory, perhaps using absorption spectroscopy. There is some recent interest in the study of the subatomic particle, the neutron, and how it vibrates, and how it vibrates differently depending on how the neutron was generated and stored. In other words, the history of the neutron, because apparently some neutrons will decay faster than other neutrons depending on how they vibrate. Again, that implies that there's a memory that's being imprinted now on a subatomic particle, the neutron. Now, a study of memory need not be limited to water molecules or molecules in general, or even subatomic particles, but may include a study of larger structures like brain tissue. Stuart Hameroff, the anesthesiologist from the University of Arizona, has studied microtubules in the brain, and he's of the opinion that the vibration found in these microtubules relates to consciousness. Well, I'm saying that it also relates to memory. In any regard, he's of the opinion that therapy involving exposure to ultrasonic vibrations may actually help people who are suffering from dementia, which is an ailment of memory. And that reality would confirm my theory that memory is impacted by the vibrations in the microtubules. We can also study memory on a larger scale beyond microtubules or water molecules and include large gravitational bodies like the planet Earth. The orbits of planets in the solar system resembles a type of repeating memory. So, with this interpretation, gravitational waves can be viewed as a memory that's emerging from the past. Presumably that would just regenerate general relativity. But it can be viewed as an extension of the particle-wave duality as well, where memories bubble up from the past in terms of probability waves, or in this case, gravitational waves. In fact, perhaps memory in general represents a generalized gravitational wave that's now beyond general relativity and would include a possible, say, quantum gravity that we actually experience as a memory. In other words, David Chalmers' qualia, thus providing a possible solution to the hard problem of consciousness.